Hello everybody, my name is Edurne Ibarrola. I am an environmental coordinator from Kunak Technologies. In this presentation, I am going to show you some results about a project in which we are participating with World Athletics. And the presentation is titled The Air Quality Monitoring and Comparison in Olympic Stadiums of 5 continents using low-cost sensors. Well, we are all familiar with the data from the World Health Organization, which says that 7 million deaths are caused because of the air quality or because of a bad air quality. So World Athletics, being aware with this, started in 2018 an air quality project to create a real-time air quality network with global coverage to help athletes to choose the best time to train and compete, and to help organizers to protect the health of athletes and to understand how air quality affects people's quality life. Most of the pilot project has been conducted in studies all around the world. For instance, there is several air quality monitors in Monaco, Mexico City, Yokohama, Addis Ababa, and Sydney. In this slide, you can see the project roadmap. The project started, as I say, in 2018 in collaboration with the UNEP and Kunak and the Spanish National Research Center. And not only the air quality is measuring in stadiums, but also in sport events and competitions, for instance in marathons. The main objective is to measure the air quality during Paris 2024. The main objectives of the project were to monitor the environmental conditions in Olympic stadiums and marathons, to see the air quality impacts on the athletes' health and performance, and help organizers, municipalities, policymakers and scientists to make better decisions. Finally, to offer and add value to the athletic competitions in terms of sustainability, increased protection of health of participants, and social awareness. In this context, Kunak-Air air quality monitoring device was used, and this device is able to measure different sizes of particles, PM10, PM2.5, and PM1, and different gases such as NO, NO2, ozone, and CO. So now I'm going to show you the results of some of the stadiums. So here you can see the Addis Ababa pollutants concentration. In the graph you can see the pollutants concentration, and the dashed line represents the CO, and its scale is on the right of the graph. You can see as well the hourly evolution from gases and particles, and we can see in these graphs the traffic rush hours related with the peaks obtaining at the morning of NO and NO2 at the end of the day, and the peaks of particles at the beginning of the day as well. So pollutants to consider when organizing a competition in Addis Ababa will be CO, NO2, NO, and particles. This is the results of Mexico City. We have 2 different devices there, one in the Olympic Stadium and another collocated with a reference station. We can see here as well the traffic rush hours, but only for NO and NO2. And regarding particles, there is a peak in the middle of the day that we are still analyzing, which is the source. So, well, pollutants to consider when organizing an event in Mexico will be ozone, NO2, and particles. Well, now instead of showing you the results of Monaco devices, that there are 2 as well, I am going to show you how we could observe how the air quality improved because of the COVID-19 when we were all of us staying at home, working, and without traveling. So you can see the Sentinel images from January to March. And in the graph you can see how the NO2 concentration started to decrease in March until summer, and they start to increase as well, again, the NO2 concentration at the end of summer, when we started to work at our working place again, and we started to traveling again. Here I show you the results from the Kunak-Air quality device installed in Sydney. It is possible to see the peaks related with the traffic rush hours. And regarding this city, particles were not a problem. However, we observed how the particles concentration started to increase at the end of last year. And the main reason was the fire events that were taking place in the southeast coast of Australia in November, December 2019. In the slide appears two different news, one with the active fires in December of last year and how they affected to the ambient air. And we could see that as well in the particle levels taken with the air quality monitoring device installed in Sydney. I show you here the European Air Quality Index, which was very poor some days in November and December because of these fires, and a graph in which we can see how particles 10 and particle 2.5 increased their concentration levels at the end of last year significantly. You can observe as well a polar plot in which the higher concentration of particles came from the west part, which corresponds to the mainland, and well, you can see that there are low concentration of particles coming from the east part, because well, this is the area closer to the coast, to the ocean. So the main conclusions of this project is that it is possible to identify the optimal time periods for training and for competitions. We can identify as well the main emission sources and mitigate the city level prior to a competition, to understand potential inequalities in training and competing conditions. Besides, we have successfully tested our methodology for short and long-term assessment. But what is missing by the moment? Related with health, for instance, what is worse for athletes to be exposed, ozone or NO2. Higher concentrations of ozone are in the middle of the day because of the solar radiation, and NO2 peaks are at the beginning of the morning or at the end of the day. Besides, we need better links with the local air quality networks. So as final slide, I would like to show you the video with the Marrakech Marathon. As I told you at the beginning of the presentation, we measure as well the air quality during events. So we carried out different pilot projects in Mexico City Marathon, in Valencia and Marrakech. This is a video of the data taken during the Marrakech Marathon last January. Well, in the video it is represent particles as well as gas pollutants, ozone and NO2. Since ozone is a secondary pollutant originated by photochemical reactions of NO2 and VOCs, volatile organic compounds. We can see how at the beginning of the race there is a higher concentration of NO2, and it is at the end of the race the ozone concentration levels are increasing. You can see there in the yellow bar. So that's all. You can ask me any doubts or any questions that you have, and this is the team of the project, and you can write any of us if you have any question and doubt, or if you want to know more about the project. Thank you very much.